Good morning, guys. So what we're going to be working on today, we're going to be working on some practice using the first derivative test. So usually what the first derivative test entails is it's anytime I'm asked about a function, if it's increasing or decreasing, if it has relative maxes or mins, and of course, if I have critical values. So remember, critical values are super critical. They're important because they pretty much tell me everything important about a graph. And I can find them by setting the derivative equal to 0 or finding out where the derivative does not exist. So the first question, it says, find when the function is increasing or decreasing. That is inherently a derivative question. If I want to know when the function is increasing or decreasing, that's asking, hey, when do I have a positive slope? When do I have a negative slope? And then where do I have neither, which is what's called a critical value. So in order to find out where the function is increasing or decreasing, I need to find out the place where it's doing neither. The place where it's doing neither is called the critical value. And the critical value is going to tell me the transition point between increasing and decreasing. So let's go ahead and find the derivative. Now, this is a really great question to warm up with this morning, so I hope we have our thinking brains on because we're going to use some product rule and we're going to use chain rule at the same time. How fun. Okay. I honestly, my coffee just kicked in and I feel really ready to go. So let's go. All right, we're going to say that h prime of x is equal to, okay, so product rule says that I say the derivative of the first, copy paste the second, plus the first times the derivative of the second. So let's go ahead and write that. So derivative of the first, well, real quick, I know that this is the same thing as 7x to the 1/2. That might make things a little bit easier. In fact, my pen can't keep up with my brain this morning. All right, e to the negative x. There we go. All right, so we'll say derivative of the first. Well, the derivative of the first is going to be 7 times, well, the derivative of x to the 1/2 is 1/2 x to the 1/2 minus 1, which is negative 1/2. So we said derivative of the first, copy paste the second, plus the first, which is 7x to the 1/2, times the derivative of the second. Well, the derivative of the second in this case is going to be e to the negative x. Okay, well, to do that, I'm going to have to use chain rule. I'm going to say derivative of the outside, which is e. Derivative of the e to the x is e to the x. Copy paste the inside. The inside function is where my x is. So we're going to copy paste the inside times the derivative of the inside. And let's go ahead and clean this up. I want to know when is this 0 and when is it undefined. All right, so h prime of x is equal to 7 halves x to the negative 1/2 e to the negative x plus 7x to the 1/2. In fact, we won't say plus, we'll say minus e to the negative x. So let's see if there's any common factors that I can take out of this. So what I'm seeing is there's a common e to the negative x, so I'm going to take that out. So we're going to say that h prime of x is equal to, in fact, we could probably take a 7 out too. Yeah, let's take a 7 out. So we'll take a 7e to the negative x out, leaving me on the inside with x to the negative 1/2. 1/2, x to the negative 1/2, minus 7x to the 1/2. Okay, so what I want to do here is find out, basically, e to the negative x can never equal 0. And so that right there is not going to be an option for this thing equaling 0, but this inside function here could equal 0. So let's go ahead and find a way to rewrite it. So h prime of x is going to equal 7e to the negative x. Let's write this in terms of negative and positive exponents. This is the same thing as 1 over 2. X to the negative 1/2 is the same thing as 1 over the square root of x minus 7 times the square root of x. Now, if I really want to combine these here, I am probably going to have to get a common denominator. So if I want to combine these, I have to get a common denominator. So let's go ahead and let's work towards that. So what I'm going to do is I can multiply by, let's do a different color. Multiply by square root 2 square radical x for x and 2 radical x, like this. So I can get a common denominator. All right, so what now I'm left with is going to be this. H prime of x is equal to 7 e to the negative x times 1 minus 14x all over 2 radical x. Okay, sorry, just taking a look at this here. I realized I factored a 7 out and I didn't fully factor it out actually. So I said I took a 7 out and I didn't. But to say I'm about to get an answer that I am not going to be so happy with. So we're going to get rid of that 7 because I already pulled it out. All right, so we're really close. We're really, really close here. So what we're going to get is 2. And the reason I get 2x is radical x times radical x is just regular x. And so really the question is here is where does this thing equal 0 and where is it undefined? Well, it's equal to 0 when this numerator here is equal to 0. So let's set the numerator equal to 0. So 1 minus 2x is equal to 0. So x has got to equal a half. So that's one critical value. Another critical value that I have is I have an x in the denominator. So that would make this function non-existent. And so I could say also I have a critical value at 0. So let's go ahead and create a number line. We're going to create the first derivative test number line. We're going to put these in order, 0 and a half. And once again, I'm going to label that this is the first derivative, h prime of x. All right, so if I plug into the first derivative a number that is less than 0, if I plug in a number less than 0, let's see, 7, e to the negative x, regardless, is always going to be a positive number. Any number raised to an exponent, and your exponent being x, it can't be negative. There's really no possibility of that because if I graph e to the x looks like this. It never crosses the x-axis. And so even if I put a negative number in, it'd just be really, really, really close to 0. Okay, so if I plug in a really, really negative number, I'm going to get 1 minus 2 times the negative number, like let's say like negative 100. 1 minus 2 times negative 100 is actually a positive number. And in fact, we actually can't even plug in a number less than 0 because I have a square root in the denominator. And so I'm going to say we don't even have any values here. All right, let's plug in a number between 0 and a half. Let's plug in like a fourth. Okay, if I plug in a fourth, 1 minus 2 times a fourth. Well, that's the same thing as 1 minus a half, which is negative, all over 2 times a fourth, which this thing right here is going to be negative. After that, I have 1/2. Anything bigger than a half, let's go ahead and check that. So if I plug in a number like 100, 1 minus 2 times 100 is going to be a negative number, all over square root of 100, which is positive. So that's going to be negative. Let me actually go back. Oh, sorry, that's supposed to be positive. My bad. 1 minus, if I plugged in the fourth, let me just show you that one. If I said f h prime of a fourth, that'd be 1 minus 2 times a fourth, which is a half, all over 2 times square root of a fourth. That right there is going to be positive. My bad. All right, so we can determine at this point that I am increasing from 0 to 1/2, from 0 to 1/2. And I'm decreasing from 1/2 to infinity. So from 0 to 1/2, I can say that I am increasing. And from 1/2 to infinity, I'm decreasing. And that's the answer right here for question number 5. All right, let's keep it going. Let's keep it moving. All right, next one. This one should be a little bit easier because it's a polynomial. Consider the following function. First thing I want to find, and this is number 6 on webassign, I want to find the critical values. Well, to find a critical value, all I'm going to do is take the derivative and find out when it equals 0 or when it's undefined. And so I get 9x squared plus 36x minus 45. Okay, so I want to know when does this equal 0? Well, it'd probably be a good idea now to factor out a 9 because everything's divisible by 9 here. So I get 9x squared plus 4x minus 5, which totally factors. Yay. Okay. So to factor this, that's going to be x minus 1 times x plus 5. So really this is saying what adds to positive 4 and multiplies to negative 5. And those options are negative 1 and 5. And you could do that with a box method too. So I know my critical values happen at x is equal to 1 and at x is equal to negative 5. All right, so let's go ahead and create a first derivative test. Let's go ahead and create this number line. So we have f prime of x. Let's go ahead and put in our critical values. So negative 5 and 1. If I plug in a number to the first derivative that is less than negative 5, so like negative 10. Negative 10 minus 1 is negative 11. Negative 10 plus 5 is negative 5. A negative times a negative is a positive, so that's positive. If If I plug in a number between -5 and 1, like 0, 0 minus 1 is -1. 0 plus 5 is +5. A negative times a positive is a negative. And if I plug in a number that's bigger than 1, like 100, I'm going to get a positive value. And so I know that I am increasing. I'm increasing from -infinity to 5, -5, and I'm increasing from 1 to infinity. For decreasing, I'm decreasing from -5 to 1. So the last thing I want to do is I want to find the extrema. The best way to do that is to draw a picture. If I go from increasing to decreasing to increasing, I can see that there is a relative max. There is a relative max at x is equal to -5, and that there is a relative min at x is equal to 1. If you want to find the actual value of the max, all you're going to do is find out what f of -5 is, and to find the actual height or the actual highest value, actual lowest value for the min, you'll just say f of 1, and you'll find out whatever that is. All right, let's keep on moving. Next question, number 7 for webassign. Consider the following function. I want to answer the same questions as I did before, so let me actually copy and paste these questions. So I still want to answer these same questions. So in general, when you're doing the first derivative test, you're always going to find the critical values first, increasing, decreasing, and then extrema. All right, so I want to know, when does this derivative equal 0? Well, I'm going to have to do a little bit of work here because this is going to be some chain rule and some product rule. So let's go and take the derivative. F prime of x, in fact, I want to write this in black, is equal to, okay, derivative of the first. That's chain rule. So I'm going to say 2. So we're derivative of the outside, copy, paste the inside, times derivative of the inside, which is 1. So that's derivative of the first times the second plus the first times the derivative of the second, which is 1. So I want to know, when does this whole thing equal 0? I'm actually going to expand it, see if I can get anything good out of it. So f prime of x is equal to, let's distribute this in because now it's raised to the 1. So I get 2x plus 12. You know what? I'm not going to do that yet because I realize it's multiplied by this. In fact, I'm going to multiply these two things together. So we're going to say, what's 2 times x plus 6 times x minus 3? So really I want to know what's x plus 6 times x minus 3, which is just a little bit of foiling. So x times x is x squared. X times -3 is minus 3x. 6 times x is 6x. And 6 times -3 is minus 18. Plus, all right, let's go and distribute this out. Remember, this is so important. X plus 6 squared does not equal x squared plus 36. Please do not do that. I know that I need to use FOIL method. I need to write this as a product of two binomials. This is x plus 6 times x plus 6. So be careful here. If I distribute that out, I'm going to get a perfect square trinomial. It's going to be x squared plus 2 times 6x, which is 12x, plus 36 is equal to 0. So let's go ahead and simplify this. I get 2x squared minus 6x. In fact, let me combine these for a minute. That's the same thing right here as just 3x. So 2x squared plus 6x minus 36 plus x squared plus 12x plus 36. So lucky for us, if I look at some things I can get rid of, positive 36 and negative 36 cancel. Those are going to cancel. And so what I get is x squared plus 2x squared is 3x squared. 6x plus 12x is 18x, so plus 18x is equal to 0. So we're really, really close. If I factor this just a little bit, I can take a 3x out. So 3x times x plus 6 is equal to 0. And so my critical values are x is equal to 0 and x is equal to -6. Let's create a first derivative number line test. -6 and 0. And we're going to label it once again as f prime. If I plug in a number that is less than -6 to the first derivative, so remember we're plugging it in here. I picked the most simplest form that I have it in. Let's plug in a number that's less than 6, like negative 100. 3 times negative 100 is a big old negative number. Negative 100 plus 6 is a big old negative number. And so this right here, a negative times a negative, is a positive. So that's going to be positive. Positive. If I plug in a number between negative 6 and 0, like negative 1, 3 times negative 1 is negative 3. Negative 1 plus 6 is a positive number. Negative times a positive is a negative. If I plug in a really, really, really big number, that's going to yield a positive. So to answer increasing, decreasing, my function is increasing from negative infinity to negative 6, and it's increasing from 0 to infinity. And I'm just grabbing that from the number line. It's decreasing from negative 6 to 0. So last thing I want to ask about min and max is, if I go from increasing, 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 to decreasing, 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 to increasing, 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 I can see that there is a relative max at x is equal to negative 6, and that there is a relative min at x is equal to 0. And once again, if you want to find the y values, which I'm not sure if webassign asks for, you would find f of negative 6, and you would find f of 0. All right, let's go ahead on to the next question. This is number 8 from webassign. X to the 1/7 plus 9. Well, I want to answer all of those same questions again, critical values and whatnot. So let's go ahead and take the derivative. F prime of x is going to equal 1/7 x to the negative 6/7. So that's just 1 minus 1/7 plus 0. I want to know, when does this thing equal 0? When is it undefined? Well, let's rewrite it as a fraction. This is the same thing as 1 over 7 x to the negative, x to the regular, 6/7. Well, there's no way this thing could equal 0, but there is a way that it could be undefined. It could be undefined if the denominator equals 0. The only place where the denominator is going to equal 0 in this instance is if I plugged in 0 to the denominator. So if I plugged in 0 for x. So my only critical value is x is equal to 0. Let's go ahead and create the first derivative number line test. All right, so if x is equal to 0, that's my first critical point. If I plug in a number to the derivative, remember you got to plug it into the derivative. Let's see, if I plug in a negative number, so let's try to evaluate this. What's f prime of negative 1? So we are going to have to use some exponent thinking here. 7 to the negative 1 to the 6/7. Let's think about what that means. If I raise negative 1 to the 6/7, that's the same thing as me saying this. 1 over 7, the 7th root of negative 1 to the 6th. Well, if I take negative 1 and I raise it to the 6th, I get a positive number. I get a positive number because a negative number raised to an even power is positive. And then I take the 7th root. So that's going to actually be a positive value. But if I plug in, say I plug in a positive 1, if I plug in positive 1, there's also no way for this thing to be negative. Again, if I plug in positive 1, that's also going to be positive. And so my only critical value is at 0. I'm actually increasing everywhere except 0. So I'm going to say from negative infinity to 0 and from 0 to infinity. And I have no extrema. And the reason I have no extrema here is because I never go from increasing to decreasing or decreasing to increasing. So that's number 8. All right, let's go on to the very last question here. All right, for the last question here, x squared all over x squared minus 16. First thing I want to do is I want to find critical values, which means I'm going to take the derivative. This is a classic low d high, so we're going to say low d high minus high, hello, d low, all over low squared. Okay, so I really just want to know, when does this function equal 0 and when does it not exist? Well, I know for sure it doesn't exist when this is equal to 0, so it doesn't exist at plus or minus 4 already. So at this point, I'm going to go ahead and note that it doesn't exist at plus or minus 4, and the reason is if I plugged in plus or minus 4, I get 4 squared minus 16, which is 0, and I get negative 4 squared minus 16, which is still 0. So all I want to do is determine the top at this point. All right, so f prime of x, let's go ahead and clean this up a little bit. I get 2x, you know what? You know what I could do? Ooh, I see something kind of fun. I could go ahead, this is kind of fun. I could go ahead and factor a 2x out of this whole thing because I see it on both terms. So I'm going to factor 2x out of the top. So what I'm left with is x squared minus 16 minus x squared. Ooh, excellent. I'm seeing some canceling. How fun. Okay. So that's going to cancel there. And so my numerator is really just going to be negative, why is that not coming to me? 32. Negative 32x all over x squared minus 16 quantity squared. So the only time that this thing could equal 0 is if x is equal to 0. So my total critical values happen at negative 4, 0, and 4. So let's go ahead and create my number line. We're going to label it once again as the first derivative. So negative 4, 0, and 4. Okay, remember we're plugging it into the first derivative. And so the first derivative, the first derivative is this right here. If I plug in something less than 4, like let's plug in negative 100. Negative 32 times negative 100 is positive, so the numerator is positive. Anything in the denominator is going to be positive because I'm squaring it. So it doesn't matter really what I plug into the denominator because I'm squaring it. So I get a positive or a positive, which is positive. Okay, if I plug in a number like negative 2, negative 32 times negative 2, that is still going to be positive. So we're going to say positive, right? So negative 32 times negative 2 is positive all over a positive value. Let's plug in a positive number. Let's plug in like 1. Negative 32 times 1 is negative 1 all over a positive value that's going to be negative. And the same thing is going to happen to positive 4. And so what I can say is that the function is increasing from negative infinity to 0. And I guess technically it's not. I'm not sure how sensitive webassign is going to be on this one. But technically it's not doing anything at negative 4. So I could say negative infinity to negative 4, and then negative 4 to 0. And then it's also decreasing. It's decreasing from 0 to 4 and from 4 to infinity. Not sure if it's going to take 0 to infinity. You could check it. It might take 0 to infinity, but technically it's this. All right, so if I want to talk about increasing, decreasing, last thing I want to talk about relative mins and maxes. If I go from increasing to decreasing, that is a relative max. And so I can say there is a relative max at x is equal to 0. And so that right there are the first five or so questions on webassign. So if you have any more questions, feel free to message me or meet during office hours today.